Hello, my name is Pisani, and this is my software system design project, BonVoyage. I decided to do a real-time ride-sharing service as my project. This is because I thought that a ride-sharing service would be a very easy application to understand from a conceptual standpoint. I think that I have a decent idea of how it works at a high level, and so actually getting into it and implementing the software design aspects of it would work out quite well because I wouldn't have to actually learn how the application worked so much. It would be more so just applying my design ideas to an already pre-existing domain and learning a little bit more about the intricacies of it. So, getting into a solution overview of the project, I went ahead and listed out some of the requirements that would be listed and completed throughout the project. Started off, I labeled some business requirements. Firstly, I had the problem statement was that the system goal was to officially provide transportation to people in need by matching riders with a driver in real time. The system needs to be able to dynamically price trips depending on the density of requests, as well as optimally provide routes depending on weather and traffic conditions. This is very similar to other rideshare apps, and I was trying to mimic the approach that they did in my own way. And by doing that, I decided to list out some main functionalities that I thought the application should have. The first being real-time matching, and this is a system to match passengers with available drivers in the area. This would do it dynamically based off of rating, the area that they're in, and how busy of a time of day it is. The next thing would be dynamic pricing, which is adjusted pricing based on the factors supply, demand, and time of day. Next, we have a route optimization, and this is effective routing that minimizes traffic and weather conditional hazards. I planned on this to use external APIs like Google Maps. The reason that we would utilize that in our system with the route optimization is because there's already some really good tools out there that are related to mapping, geolocational data, routing, traffic minimization. So it is good to use those tools and minimize any application development that doesn't need to be there. For the rating system, we are allowing our passengers and drivers to review each other with a rating. This is out of 5 stars. This is also utilized in the matching system. So a user with a lower rating would be less likely to match with another user that has a higher rating. Next, we have the secure payment system. This is a payment processing for users supporting major credit cards, and drivers would be able to have access to set up connections to their bank deposits or bank accounts so they could easily get paid and so that customers can easily pay for their rides. This will also utilize external tools that I'll talk about later, just to make the process easier and not to design anything that doesn't need to be designed. Getting into our users, there is 2 main users in this application use case, and that would be the passengers and drivers. The passengers are looking for quick and reliable matching with drivers, a clear and transparent view of what they will be charged, and easy booking and payment offered through the UI. Drivers, similarly, will be looking for quick and reliable matching, just like the passengers. They would have the ability to work whenever they need, so just turning on the app and searching for rides, and just like that, they can start working. We want our routes to be optimized and efficient. We don't want anybody to take rides that are longer than necessary. That's not good for anybody. And a fair and speedy payment for their work, where right after they've complete their work, they can see that the payment is being processed and sent to their account. Getting into some of the business goals for this project. Some of the things that I thought were important were satisfaction and retainability. This is making sure that drivers and passengers want to continue using the system after they use it the first time. After they use it once, they can see that it is efficient to use and that it is easy to use, and they want to continue using it after interacting with it. Next is the revenue aspect of it, which is related to the dynamic pricing, really. And this is talking about how the dynamic pricing model will charge passengers and pay drivers fairly, while also making a profit for the actual company that is utilizing it. And lastly, we have the market share aspect of it, which is just acquiring a large portion of the market by providing excellent service. This is basically just saying doing it better than the competitors, since this is already a pre-existing domain. It would be important that the design and the implementation and all of the different services lead up to something that is able to compete in the current market. For the non-functional requirements, we listed out a couple of them. We have the performance requirements. This has to do with stuff like scalability, which is scaling up the system. At a baseline, we would want at least 100,000 passengers and drivers to simultaneously be able to use the application at once with no issues. And then during peak times, we would like it to support 1 million concurrent users if necessary. Next, we have the matching requirement. This is related to the guaranteed matching response time during peak hours being at a maximum of 30 seconds and going all the way up to 5 minutes of wait time during off-peak hours. This is just making sure that we design an application that is efficient and fast with its processing, and that even during off-peak hours, it's still able to complete its job during a reasonable amount of time. For latency, we want our UI interactions to be no slower in populating on the screen than 500 milliseconds or half a second. And any exceptions to this would present a working dialog, that being like a loading screen or just something that tells you that some sort of loading is happening. For optimization, we want the route optimization to take no longer than 3 seconds to complete. This is for initial calculations for routes, and also any recalculation that needs to be done during the routing process, so that if an accident were to happen and the mapping service and the route mapping service would be aware of it, it would be able to recalculate rather quickly. Throughput, that is the system being able to support 5,000 transactions being processed through the system at any given time. This is basically saying that the scaled up application device itself can handle a lot of requests, and it's sort of related to the scalability, but it's talking about total load at a given time. For security requirements, we have things like authentication, which is the users being able to authenticate through a username and passwords, also two-factor authentication. Authorization, which is passengers, drivers, and administrators all have roles placed on them that enable different permissions. Encryption, this is data transmission being secure and safe for all information being processed throughout the system itself. Privacy, this is user data is handled responsibly in accordance with the Federal Trade Commission. This just means that the application has to use best practices in order to make sure that user data is handled safely. Getting down into the maintainability requirements, we have modularity, which is the code base should be partitioned into independent subsections that build up to an organized and maintainable structure that it is easily to update using Git versioning control. This is basically saying that you're using best practices to design your system. Modularity is something that is well known and common within the system design and software design space. So it is important that our software meets those standards. Documentation, all classes and APIs shall be properly documented with code linting and readmes. And testing, where proper unit integration testing is across all the developed codes and classes. Any additional requirements we have would be related to availability, which is that the system should be able to be usable and operational with 99.9% uptime. That means that at any given time, the system should pretty much be available to use, aside from maintenances and unexpected downtimes. Recovery, which is data backups, are frequently taken and stored with the ability to quickly restore lost data in the event of a system failure or data loss. This is covered later in the actual deployment side of things. And now getting into some of our actual design process, we'll start off with the use case diagrams. I'll zoom in so that we can see a little bit better. So I came up with most of the essential use cases that are related to the system. Passengers and drivers should be able to save their card details. This is for paying for rides or getting paid. And then let's get into the passenger side of things. The passenger is able to request a ride. That can extend into the navigate ride or navigate trip use case. And then at the end of a trip, you might rate a ride, and then also you might leave a tip. For a driver, very similar to requesting a ride, they find passengers, and then they get into the same use case scenarios where they navigate a trip or rate a ride. But there is a separate use case that only applies to them, which is rejecting a ride, and this would just be another subsection for the driver that they're able to do as an option. And then passengers and drivers are able to register and log in. Next, we are going to move on to the domain model. This explains a lot of the real-world objects that are implemented through the system and their attributes that might be involved with them. The things I came up with were a lot of things that were related to the actual trip itself, or the user being the driver or the passenger. So we have the user, driver, and the passenger is a user and extend it. The driver has a vehicle that it uses. Users have ratings. Users have locations. And then the trip utilizes all of the location data and the user data to actually perform its actions related to the ride-sharing service. And then finally, we have things related to payments, where there's either a driver payment or a passenger payment. And from that, I was able to create this class diagram, which kind of fleshed it out a little bit more. And from this, I was able to create the driver and passenger objects that go into a user ride manager. And this basically manages the user's classes itself and does the matching based part of the application. And it can also add passengers if there was ever a passenger that needed to be added to a ride. And that user ride manager, along with the route manager and the payment manager, are all passed into the trip manager, or they're initialized by it. And the trip manager makes trips with which it can basically, a trip manager can manage and pump out a bunch of different trips and create this thing called a ride trip that I made, which handles all of the different aspects of it, where it basically like compiles all the data into a usable object of data that can be used by the system to perform the ride sharing service, and also do things like update the rating and other things like calculating the payments by the payment manager, creating routes, which would utilize like Google Maps, and like payments, which would utilize the other external payment processing. For our sequence diagrams, I went and made 3 of them, the ones that I thought were related to the system and most important to it, the flows in general. And what the request ride would do is it would set a location. This would be done by the passenger. And then the system would get the passenger location. You would select the vehicle type you would want, so there would be a couple of different options that you could select from depending on how many passengers you had or the luxury of the vehicle that you wanted to ride in. And then the user would select a time, select a destination, and confirm the ride. And from there, the system would kind of get to work. It would get the passenger ID and start the create match process, where the system would go ahead and calculate based off all the data that was given to it, and find a driver. And eventually it would, after it was done calculating, the system would find a match and return that to the passenger. Moving on, we have the find passenger flow. And very similarly, the driver would log in, authenticate, just like the user, and then it would search for rides, and the system would get the driver ID based off of that. It would create a match, just like the user would, utilizing the same create match functionality. And eventually it would match up drivers with passengers. And as an extension of this, you could reject a ride. This would be the driver clicking a button on the UI. And basically that would reject the ride, put you back into the matching algorithm and find another match, but it would also remove the passenger that it rejected from the pool so that it could no longer get that user again. And lastly, we have the navigate trip sequence diagram. And this is the main flow of the system related to, it's the meat and the potatoes that does most of the functionality. And this would utilize the trip manager, which creates trips, and then it calls route manager and payment manager, and it calculates the route and the payment, and then it creates a ride trip within the trip manager to bundle all of that information. And then the trip would start. The trip data would be displayed to the drivers and passengers, and then eventually, after the trip is completed, it would let the users and the driver and the passengers know that the trip is over, and then it would charge the customer and pay the driver. And an extension of that, you could rate the driver, and you could also rate the passengers. And then that would go to the system and update the rating of whoever got rated. For the state diagram, this is kind of just showing the different states of the system. So like this, there could be a state of logging into the app, and then it kind of diverges off into the driver and passenger flows, where the driver would turn on accepting rides as a state. Passenger would enter ride details, request a ride, and then they would meet back up to match up passengers and drivers. And then there's the driver that could reject it and end the whole process to start up the matching process again. And then there's other flows like picking up the passenger, driving the passenger, charging the passenger, paying the driver. The users rate each other, and the passenger options for tipping. Next, we have the component diagram, which describes the different services and systems and their interactions. We have 4 different subsystems and services, being the authentication service, the user service, the payment service, and the ride service. This works with, let's start off with the user service, which manages things like logging in and matching drivers and updating users. The ride service, which is related to the routing, the trip management, and reaching out to the external APIs to get information related to trips, so that it could use it for its calculations. The payment process manager, which would manage the payment aspect of the system and also reach out to the external payment processor, which would interact with external APIs. And then the authentication service related to the login and authentication process for either login, register, or logging in through two-factor. For our deployment diagram, we have the whole entire flow of all of the things deployed. So we have the passenger and driver that we're assuming to be using mobile phones, just like other ride-sharing services that people use. And when it connects to the application, any sort of inputs that are immediately entered or processed throughout the system are put onto a AWS load balancer. This is used by the system in order to know whether it needs to scale up any of the different components or systems, depending on the amount of users using the system at a time. The application service, just like in the component diagram, it consists of 4 different services, that being the user system, the ride system, and the payment system, as well as the authentication system. And any data that is being stored by this system would get passed into an Amazon Aurora PostgreSQL database. And also, as a backup, there would be another instance of this that would work as an asynchronous replication to guarantee that there was no downtime. Similarly, the BonVoyage application system interacts with Google Maps locational mapping and data and mapping APIs. This would be the ride system interacting with that, as well as the payment system interacting with PayPal, which would also be reaching out to external APIs. So for some of the classes that I described earlier, I went ahead and made some outlines. Firstly, we have the user. This consists of a user ID, username, password, role, email, phone number, rating. This is very similar to the attributes that were listed out in the class diagram. Some of it is a little bit more fleshed out, and some of the methodologies and methods and functions that are listed are a little bit more in depth or stated that weren't. So we have things like update profile, get role, view rating. The passenger, which is an extension of the user, has unique things like a payment method and a passenger ID. And then the driver has the vehicle ID and a driver ID, but it also has a bunch of different methods that it could use that are specific to the driver. Things like the accept ride, update location, view earnings, get route, get driver location. For the trip, we have the trip ID, the status, the start time, the end time, the driver, and the passengers. Passengers being an array of passenger objects. And methods being get trip info and get trip ID. Location, this being latitude and longitude, which would be translated into an address, as described in the class diagram system. And also you would be able to calculate distance given those values. And for the rating system, it would have rating ID, user ID, rated user ID, a score, and any comments that were left along with the associated score. And this would do things like submit rating or get the average rating, which would compile all of the user ratings and average it out. And then I made some database outlines, which are actual real SQL queries that I created. I won't go too much into them, but they're essentially utilizing the information that I had before and important things that would be stored within the information. So we have tables like the user table, which has a lot of the same information that would be shown in like the class outlines, but reflected in the database for pooling data and any operations that need to be done. So we have the users, the passengers, drivers, the trip table, a ratings table, and yeah. So for the design patterns and best practices, I utilized a couple of different things that we learned throughout the course. The system that I created utilized the expert pattern, which is that most of the classes that were used utilize and perform responsibility of actions to the same classes that holds the information for it. This is done by things like the trip, driver, and passenger, and all of the attribute information needed in order to perform the actions is done by those classes. Then we have the creator, which is the trip manager creates and manages the use of the trip object that it creates. This allows it to create and handle many instances at the same time, and it also decouples the responsibility of the trip class. And then the controller is the trip manager and the user ride manager actually have a good workflow of creating, updating, and managing trips and matching rides together. This coordinates the interactions of both these systems and separates the control while also being organized control flows. We also utilize principles by the solid methodology and design principles. We did single responsibility principle in this project, and that is classes like the route manager, trip manager, and payment manager are responsible for only one aspect of the system, handling different interactions between them. And also the list-off substitution principle, which is the driver and passenger subclasses can be used interchangeably for some actions where a user may be expected. Lastly, for design patterns, for Gang of Four, we used a factory pattern where the trip manager and payment manager act as the factory pattern because they create instances of trips and payment objects. And then for some justification for the external tooling and APIs, for load balancing, why we decided to use the AWS load balancer. It's because we wanted to use it in order to scale up our system to be able to handle 100,000 to 1 million users. So we needed to use a load balancer in order to accomplish that. This would take things like the route, trip, user, and payment services and load them with enough resources needed to complete their actions within a reasonable amount of time. And it also allows for the requirements to scale up based on the needs of the system, given a large enough amount of traffic. For the database, I decided to use the Amazon Aurora PostgreSQL database and the backup in order to have high performance and scalability. It's a feature of it, and it handles high transaction loads and large amounts of concurrent users, which also goes back to our scalability. The backup database operates as an automatic failover system, so that makes it so that the system would have minimal downtime. And also there's some security benefits like encryption of data on transit for any database interactions. For the routing and mapping APIs that I used, I decided to use Google Maps as an integrated part of the deployment for the system because it has really great locational data and mapping tools for anything geolocational related. And also it can display things like street information as well as like other geographical data. And it also offers data related to real-time traffic and can optimize routes based on current traffic conditions that would otherwise strain the application system if we were to try to replicate it ourselves. Lastly, for the payments, I decided to use PayPal because it's pretty well known and it's pretty built up as a system to be integrated into nowadays. It's highly accessible to a large amount of people, and it's known for facilitating secure transactions for almost 20 years at this point. It's supported by all major credit card companies, and PayPal features, just like the other systems, robust encryption, making sure that any of the user payments or the user information is secure when we're making any payment transactions. It also has the ability to work on the global scale. So if we ever wanted to make this application global, it would make it a lot easier because we wouldn't have to, we wouldn't be limited by our external APIs and applications that we were using. So yeah, some final thoughts and next steps that I kind of discerned from doing this project is I went from having a pretty high level understanding of something like a user rideshare application through that I already had through things like Uber and Lyft into a more detailed idea of what goes into creating something like this. Even though I excluded some of the intricacies that are kind of used to build up that system, I can still see all of the little interdependencies and things that go into it that you might not see at a like baseline level. I was able to better understand all of the different aspects through a design standpoint. It is kind of hard to conceptualize what goes into different classes and what goes into different flows without kind of going past it sometimes. Sometimes you'll complete a step, like you'll do the domain model, and then you'll have to go back later and change it up because you realize that something later down the line doesn't make sense based off of some new understanding that you have developed. And I think that's good because it's all part of the design process and making sure that you make a robust system that actually works properly. Thanks for taking the time to listen to me explain my design process and show all of the different things that went into it. I hope that you learned something and have a good day.